Google course is using given example to explain how view model works. But in my opinion, this is quite a long view model, quite long example, so I decided to use it last example in view model explanation, because this is long one. Okay. If we start explaining how view model works from such example, it will be killer probably. So this is why it is last in the current topic, not the first. So let's clone it and get from version control the usual way, Command V, MathTrainer clone, and trust project. So let's run it to see what it is doing. It does have some useful stuff. It's not just long thing. So originally it was guess a word and rehashed letters of a word. And somehow you need to pick a correct word. But in most words, if you rehash letters, it will be extremely tedious to guess. So I replaced this logic. Now it is just count. Okay. If you answer incorrectly, blah, 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 and you click submit, it says wrong answer, blah, 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 and it will say try again. So what did we learn from it? How to change appearance of the text box when we need it. In this case, change to red, display some message there. So it is in the code. Definitely this is useful information. Another useful information. You see that this is centered, this is centered. This is off center. So how they did it? And this is column, and as they said arrange, horizontal arrangement, center. So it applied centering by default. Okay. But they used alignment property of modifier for this box to override it for specific box. So it is definitely useful information. How to behave everything the same way in a column. Like align everything to left, but center something. Or align everything to left, but something is aligned to right. Okay. So they use the property of the column to center this stuff, but they use it modifier of this box to align it this to end. So left it is start, right at this end. So also useful information how to deal with GUI this way, right? There is no pages here. It is just updating the same screen. So let's put correct answer. And when you do correct answer, it go to submit, it updates this, and update score. And it will update count on the top. Okay. Eventually, when you reach the end, it will pop up text box, your score. Okay. When you click skip, it will just take you to, no, that was submits. When you click skip, it just takes you to another answer, another problem. It will update count. Definitely, it will not add to your score because you just skipped problem. These problems are not stored anywhere. They just generated as we go, for simplicity. Definitely, if we want to generate this problem ahead of the time, problems ahead of the time, we can avoid duplication, because this technically can duplicate problem because it's just random. We could avoid duplication, and this way we can also navigate. Go to next, go to previous, let's go back to previously skipped problem. It would be possible, but now there is no way to go back to previously skipped problem because it is generated, and after you go to next problem, content is discarded. You don't have it anymore. Okay. So how view model works? let's see. In UI, you have your game UI state. This is a problem which is here. Problem count, it is what is displayed here. It is 3. Score displayed here. So it is state, right? Okay, score. Is wrong answer. It's also state because somehow you need to trigger this red color. So this is triggering red color. So when it is false, it is just normal. When you type something bad and print submit, this goes to true, and it is triggering this. So this is also part of the state. And game is over is triggering pop-up screen that tells this is your score. Okay. So this is everything, val, in game UI state class. Okay. What is state but is not here? Definitely not this one, right? This is also state of the UI, but it's not stored here. Pop-up on and pop-up gone, right? And also, this is also state UI. Remember that you cannot type inside of text input without having some state variable, right? This is we learned in the beginning. So this is also state, but it's not stored here. It was in the original example from Google, and this is how they did it. So I said, okay, fine, good enough for you, good enough for me. So this also part of the state, but it's not in this object. Why? Because technically, logically, it is separate. So since it's logically separate, why do we have to push everything religiously into one piece? If it is completely different piece from logical point of view. Okay? So let's open ViewModel and see how this stuff is stored in ViewModel. ViewModel. Number of problems, it is just variable. It doesn't have to trigger screen. Something else is triggering screen, so no, sorry. It is just this, it's constant, it's always 10. Okay. It is number of problems, it's literally always 10, it's val. Okay. This is good candidate for settings to change variable, this one, right? Problem factory. Somehow we need to make new problems because when we click next or skip, you see it's creating new problem. So when I reach end, eventually pop up, congratulations, you scored 1 out of 10. Thank you. Okay, good achievement. I'll play again. So somehow you need to create problems. And if you create a problem with value, another value, somehow you need to create the problem smart way. So you need some smart logic to generate these problems. Right? So essentially, we need a class to create other classes, other objects of other classes. So typical naming convention, it's a factory. Factory, it's an object that is creating other objects. So I have a problem factory. So how do I create problem? I call method create problem of problem factory. That gives me problem. Right? So initial state, UI init state, I customize it getter, and it is problem count is 1 and just random problem. So this will be UI init state. So when I initialize immutable state flow, I use that getter. You see, UI init state, so it will call getter, and it is this one. Why do I couldn't use constant because it is different problem each time. So I created getter for the property, and when I assign this piece, it will call getter because it's a property. Okay. So this will be first thing that we see when program starts. UI state of this. Okay. This variable is used when we type things here. Okay, user input. It's not part of the state. This is how it was originally, and this is how it was in final. It was this was lab. It was original code and final code. In final code, it was like this as a solution. So I decided, okay, it is separate, logically separate piece. We don't have to stick everything into one object. So I decided, okay, let's keep it separate variable, this one. All right. Reset game is taking us to init state. So problem count will become 1 because it will be restarting first problem. Right? And problem will be the random one because I call factory get problem, get next problem. Now it becomes tricky. And because what happens on submit and on skip, we have to apply logic thinking logic, because we have to think, right? It's not just something that immediately obvious. I spent time thinking and I cleaned it up because it was even longer before. So in the original solution, it was longer. So let's see, starting from the top, what happens on skip, on the skip. On the skip, we have to update this, we have to replace this. And score stays the same. So on skip, and we also need to remove this thing, because whatever was here needs to be replaced. So you see, skip is updating this, cleaning this one, and keeping this one. We don't change. This is new. So what we see? UI state update, previous state, problem count. If problem count equal to number of problems, we do not go to next problem, we pop up dialog game is over. So if I'm at the last step and I click skip, it will not give me new problem, game is over. This is what happens. When it is last problem, pop up, game is over. Otherwise, I'm copying previous state. I replace problem with new problem from factory. I change count to next one. And if it was red and I click skip, it should become original. I shouldn't inherit red color into new problem, wrong answer. Color into new problem. Looks logical, okay? This is what happens on skip. Questions? Okay. So I rewrote this logic, and now it is shorter than the original. So on submit. What happens on submit? This is a little longer because you need to check answer. This is the problem picked from state. Okay. I'm updating the state, so this is current state. I need to check if answer is right. So what I call problem check answer, and this is user answer. So problem object has a method check answer against user answer. And it is returning either problem, either right answer, wrong answer, or bad input. It's one of the three. And if it is right answer, this one, I'm here. Otherwise, it is the wrong answer is true. It becomes red. Okay. So if it is right answer, I'm here. Otherwise, it becomes red. Okay. So what if it is right answer? It is this if. Also, there are two choices. If problem count is equal to number of problems, it means we're at last step. We copy state, but we do not create new problem. We pop up dialog box. Game is over. Congrats, right? Since it was right answer, we increment score by 1. And if it was red, but it shouldn't be, we change it to false. I don't know why I added this part. If it is right answer, it shouldn't be. Yes, it can be. Because it was red due to previous state, but you type it right answer, clicked it OK, it is right answer, so it needs to override red to default color. Okay. Because you can provide right answer after wrong answer. So this is why it is changed to default color. What this part happens if it is not last problem. This is last problem. So if it is not last problem, I definitely update score by 1 because it's right answer. I clear up red because red would be, even if you type right answer into red box, red, you need to clear up red. Then I'm creating new problem, so I assign new problem because it's not last one, I need to update it. And I update problem count in the copy. Okay. And I'm clearing up this box. So update answer input, it is just clear up of this box. Update answer input with empty string, it is just clear up of this box. So this is the logic of updating state in this program. I clean it up, it was longer. It wasn't longer because it was words, it was just longer because of the person who wrote it. Okay. Right. Questions? So this is about UI, UI state. GUI, it is just long. I already emphasized things like how to change. There is a way to change this frame color, look up how it goes, how it's done. There is also interesting part that you can override alignment for a piece using modifier. How problems are generated? Yeah, I was just sitting and thinking how to make problems that are not 1 + 1, but some kind of things that we can calculate, but not 1 + 1, something smarter than that. So what did I do? I did exercise for myself using inheritance. So let's see how it is done. I think it is reasonable. So in data, I have a factory. So what is the problem? You see, this UI is using type problem. Problem factory is returning problem, and problem is stored here. So what is this? This one. It's a problem. What is actually problem? Problem is defined here. It's interface. It is whatever that has a text and whatever has a function check answer. So technically it can be anything. It doesn't have to be math problem. So this is more general than math problem. This code is called MathTrainer, but it could be any kind of trainer, essentially. But of course, you need to change problem generation for it. Okay. Problem grade, it is just enum, returning right answer, wrong answer, invalid input. So problem can be anything. But where's the logic? Logic is in problem factory. Problem factory is giving you problem. And if you did problem factory, it can be any kind of trainer, not just MathTrainer. Okay. So we have algebra problem. Algebra problem, it is abstract class. Implementing problem interface. It has property answer in integer. So if it is algebra, it expects integer answer. Okay. And I'm overriding check answer because now I can check if it is right one because I know the answer. Okay. So using try, because I need to check what user typed, so I need to convert it into number. So convert it to double, it can throw exception, and if it throws exception, I return invalid input. Please notice that try and catch in Kotlin can return value. So I can assign literally try and catch block as a function. So it's also new information because we didn't see it before, right? From Kotlin. So in Kotlin, try and catch block can return value, and you can assign it as statement. In this case, it is assigned as a return value of a function. Also interesting part, right? Right? And since user can type .0, this will be double, but not integer. I need to compare integers and doubles, so yeah, it's always issue in programming, right? When you compare integers and doubles, you compare 3.0 with 3. It doesn't have to be true. Depends on, or something like this. So I compared this with tolerance. So I created some high tolerance, right? And I compared this user answer with entered value. If it is less than tolerance, it means right. Okay. To avoid issues like 5.0 is not equal to 5. Who knows? Okay? Sometimes it happens when we compare floating numbers and integers. Again, this is abstract class, so it is implemented elsewhere. So I have addition problem and subtraction problem. Addition and subtraction problem just have two numbers, right? And answer and text. Okay? For answer, it is just calculation. For text, it is template, right? So A goes here, B goes here, and definitely for subtraction problem, it's minus. Okay. And for addition problem, it is plus here, and answer, it is just two numbers added. So this is not abstract class, it's just data class. So my problem factory is using either addition problem or subtraction problem. If we create additional implementation of problem or algebra problem, we can mix additional problem like multiplication, divisions, so. So my problem factory, what does it do? I just use it some constants for largest value, smaller value, tried to apply common sense and random number generation to get it out. Okay. Okay, so it is to avoid simple problems like 2 plus 2. Okay. So you see, larger, it is between this constant and two values, larger of the two and smaller of the two. I generate larger number and smaller number. Then larger, it is between this larger value and larger value until the same. And smaller, it is also between smaller value from and ending with larger number. After this, I do if, next random, true or false. So it is randomly either addition problem or subtraction problem. because random Boolean, it is one of the two, right? True or false. In addition problem, for first number, use larger minus smaller, and this is smaller. And for subtraction, it is just larger and smaller to avoid negative answers. And again, it is just sitting and brainstorming for a couple of, no, not a couple hours, less than a couple hours, for about an hour. And after this, to test it, if it is behaving right, so I create a test, and test is just nothing special. It is just printing things, not this test. It is here. What does it do? Not this one, this one. What does it do? It has create problem function that is running 20 times, 25 times loop, and it is printing generated problem. So what does it check? That code is not crashing, and I see what kind of problem it's getting. So just common sense. So tests can be used for just checking Kotlin code. Because when you're inside of Android Studio, you cannot do console problem, right? But in this case, you probably want to see what kind of problems it generates, like 25 problems to see what kind of stuff it's generating. Otherwise, you may want to tune those constants so it doesn't generate something crazy. Okay. So this test was used to see what it is producing and to tune those constants to make something sensible. So let's see, let's run it. Here it is. Okay. So when I made this factory, I ran this test and tuned those numbers to get something not too elementary and not overwhelming. Okay. So it was also exercise in inheritance in Kotlin. So it was on purpose to demonstrate interfaces, abstract classes, and two implementations of those abstract classes and factory. So it is demo, essentially, of additional Kotlin features. Okay. Questions?